I just want to order one drink. Why is it taking so long? I've been standing here forever.
I'm really sorry. I'm the only one at the counter right now. Customer just keeps coming in.
This cafe has only one counter and one worker. Customers arrive about 10 people per hour, but each customer takes 5 minutes to order and pay.
Time is money, you know. People behind me getting annoyed too.
If this keeps up, I'm leaving.
Each waiting customer costs the cafe 3 ringgits per hour. On average, more than 4 customers are waiting in the line.
Customer keep on waiting. Should I add one more counter and hire one more worker?
One worker costs 9 ringgit per hour. The owner must decide which option gives lower total cost. Hi, next order here.
Wow, this is so much better. I barely wait at all.
Yes.
Can I order one iced latte, please?
One ice latte.
Yes.
Oh, I see the
Thank
receipt.
you.
Wow, nice. Now I won't be late for work.
Here's your ice latte.
Thank you.
Now the cafe has 2 counters and 2 workers. Customers are served faster, so waiting time is reduced. Fewer customers are stuck in line, which lowers the waiting cost.
I pay just a little more for 2 workers, but I save a lot of money because customers aren't waiting anymore. This is the best decision ever. Yeah, right?
Although hiring another worker increases service costs, the total cost is lower because waiting costs drop significantly.
So now the calculation. So the current system, Gigi Coffee has 1 worker, so S equal to 1. So we have lambda and mu. Lambda is 10 customer per hour and mu is 12 customer per hour. So in this question, we need to search the W, which is the average time customer in the system. So we include all the information that we have. So 1 over 12 minus 10. So we got 0.5 hours average time for the customer in the system.
To calculate the total cost, we are using the formula when the waiting cost is based on the time in the system. So our service cost is 9 ringgit and our waiting cost is 3 ringgit. So we substitute into the formula SCS plus lambda WCW, and then we found that the total cost is 24 ringgit per hour.
Next, we now consider the system with 2 servers where S equal to 2. First, we calculate the utilization factor by using the formula and substitute, and we get 5 over 12. Using formula, the probability that there are 0 customers or units in the system, P0, and we substitute, and we get 7 over 17. After obtaining P0, we substitute it into the Q length formula to determine the average number of customer waiting in the queue, LQ. And finally, after using LQ, we get the average number of customer, which is 125 over 714.
Now, we will have to find L, which is LQ plus lambda divided with mu, which we will get 1.008. And then we will have to find W, average time of customers in system, by dividing L with lambda. and we will get 0.101. Lastly, find the total cost, which we will get Rm 21 ringgit and 3 cent.
Now, I would like to explain the arrival characteristic of the GG First, the size of the calling population is considered infinite. This is because the cafe is open to the general public, so the number of potential customers is very large. Even if some customers are being served, it doesn't affect the arrival of other customers. Next, the pattern of arrivals at the cafe is random. Customers do not come at fixed time. According to the given information, the arrival follows a Poisson distribution, with an average of 2 customers arriving every 12 minutes.
Next is the behavior of the arrival in GG Coffee. So, in GG Coffee, most of them are patient customer, which is the customer wait in the queue until they are served and do not switch between the lines. Waiting line characteristics. The cafe operates under a limited queue system. A queue is limited when it cannot increase to an infinite line due to physical restrictions. Only a certain number of customers can stand and wait inside the cafe. If the cafe becomes too crowded, new customers may decide not to enter or leave, so the queue cannot grow infinitely. This applies before and after adding another counter. Adding another counter reduces the queue length but does not make it infinite. Queue discipline. The cafe follows FIFO queue discipline, which FIFO means customers are served in the order they arrive. The customers arrive, line up, place orders, and pay one by one at the counter. Customers are still served in order of arrival even with 2 counters.
For service facility characteristics, the initial system uses only one counter, which is S equal to 1. So the number of channels is single channel system because the cafe has only one open counter. And the number of faces is single face system, where customer only receives services from one station, and the service time distribution is random. And when the cafe added another counter, which is S equal to 2, the number of channels is multi-channel system because the cafe has now 2 open counter. And then the number of faces is still single face system, and the service time distribution is still the same, which is random. For system configuration, when the cafe has only one counter, which is S equal to 1, the system is single channel single phrase system, where customers wait in a line with only one open counter. And then when the cafe added another counter, which is S equal to 2, the system is multi-channel single phrase system, where customer waits in a line with 2 open counter. And finally, for the conclusion, the owner should add a second counter. This is because with only one counter, the customers would have to wait long in the waiting line, feeling unsatisfied, causing the waiting cost and the total cost higher even when the service cost is lower. By adding another counter, the service cost is increased. However, the total cost is lower because the waiting cost is reduced significantly, and the customers won't have to wait long in the waiting line. And finally, what have we learned from this project is the queuing theory helps us to determine the right decision by lowering the total cost and keeping the customer happy and satisfied at the same time.